What? Oh, okay. Okay, so we continue our lecture. So previously we are focusing on apply the equation and what we learned so far. Again, direction of velocity always tangent to the curve, and acceleration always pointing in a normal direction if it's curvature. Um, and then when it come to solving question, you have normal and tangent direction. So rho is the radius, and there's the equation for acceleration, right? Okay. All right. Next, we look at just now we use normal and tangent coordinate. Now sometimes we use cylindrical coordinates, which is the r and theta. Okay. So polar coordinates, location of the particle, for example, what you see on the screen here. Let's say you have a curve motion particle red dot, and this curve origin from 0, right? So this is the r, the position in the polar coordinate, r from the first location, initial location O, to the path here. This r is called radial coordinate, but you can just memorize it as position, right? And we always have one reference line when we come to polar coordinate. So there we have a theta reference line, so on. So this reference line is always horizontal to help us to solve more easily. And normally this reference line is a line or parallel to the x-axis given in the question. Okay. What is need to highlight is that when it comes to polar coordinate, the theta always positive when it's counterclockwise. This theta is anti-clockwise positive when you deal with polar coordinates. Okay, so be careful. This is the only one part that you need to be careful when it comes to polar coordinate, a bit different from the previous one. Okay, then again, you're dealing with vector. Now you have two directions, one is r, one is theta. So same, your unit vector also in the r direction and theta direction. This now is in normal direction and tangent direction, right? Now you deal with r direction or radial direction. You go along the radius of the curve, so radial direction. Going out is positive, going in is negative. So the angle is positive when it's counterclockwise. Okay. Then on the object itself, again, you draw two lines that represent the r and theta. What does it mean? Tell you, if it's going out, r is positive. If it's going in or going up in this direction or anti-clockwise direction from the reference line, is positive. Okay, then you have your vector unit. This is vector unit like your ijk in your vector analysis. Same here, we use ur and u theta. Previously, we used ut and un, but we are now in the polar coordinate. We use u theta and ur. Okay. So, okay, so this is what I explained just now. The direction, where it's positive, where it's negative. And one interestingly is that the r and theta always 90 degrees to each other. Okay. Position, again, we are always repeating position, velocity, acceleration in chapter 1. So position, how we name the position or how we write the position, r equal to r dot ur, magnitude and direction. The blue color you see on the screen is the magnitude, and ur is the direction. Where's the direction? Is along the radial direction. Velocity, how you find velocity? Again, this is position, this is velocity. How you find velocity? Differentiate your position with time. So you have a r dot here. Okay, you have a r dot, v equal to r dot, which means what? You need to do dot product. This is the vector. So dot product of this one dt, this one also dt. So freeze this one, differentiate this one, plus freeze this one, differentiate this one. Go back to appendix B about vector. Okay, so use product rules. This one is in the vector chapter. You will get something like this, like what you see on the screen. Okay, then you can write in this form, v equal to r dot ur plus r u dot r. Okay. So to evaluate this one, is a vector. So this alone is a vector. So vector along this line, does it change does it change with the time? Does UR change with time? This vector, no, because it's always follow the radius. So yeah lah. So when it always change, then at the same time we can write magnitude of UR always 1 because it's do not change and it constant with respect to time. Okay, the rest you read on the screen. For diploma, you don't need to worry about the derivation. Okay, so what happens if you change the angle? What happens if you change there's an acceleration, means there's a change of position already, right? So this is the origin one, UR, and this is the change of velocity with an angle, okay, delta. So you can find a vector product. So you know that this is starting, this is the end. So when you join the end, this is the resultant. Starting, go towards end. So you join the tail and the head, you get resultant. So this, let's say this is your A, B, and C. So your C equal to A plus B. Okay. So you have the first equation, U prime R equal to UR plus delta. This one is vector lah. Okay. Okay, then for a small angle, you know that from previous slides also, delta R have magnitude, we are very, very small. You can use this equation, 1 and plus the delta, this one. So delta UR, you can write in this form, right? So this one have magnitude and direction. Then you substitute back, you remove the delta with the limitation, like what you learned in your previous chapter in section 1, right? Change delta to D something, same with this one. So you substitute, you arrive lah. So for diploma, you don't need to worry about the derivation. Okay, all these are derivation. What's important is application of this one. New set of equation for polar, V equal to UR plus theta U theta. Okay, for polar coordinate. Okay, important. Then then you can draw the V vector on your free body diagram. VR is along the R radius axis. V theta is along the theta axis. So you have VR and V theta. From here, you can find the resultant. Okay. So you can find the resultant by using this one, square this one plus this one, you find the resultant. And also you can form a trigonometry equation, tangent sine cos from here. Okay, to find that angle. Okay, like what I show you on the screen here. Okay, so how you find the magnitude? Again, square the magnitude. Again, replacement. So R dot UR plus R theta dot UR. This is the second equation beside the previous one. Previous one is acceleration, this one. This right on the screen here. Acceleration equal to this one in normal tangent. But this is when it comes to polar, this equation is important because now you need to find the change of radius and also this one. Okay. Acceleration, same procedure. So you differentiate this one, right? You will reach one equation. So I won't ask you on derivation. So it's a quite complex. You don't need to memorize. Only you need to, okay, all these are skip lah, the derivation steps. You read lah, on the screen you read what is important for you guys. This one you read lah. So it's a derivation steps, how to find the equation. Just now, our acceleration, we do the differentiation of this one. The VT, you differentiate this one, quite lengthy. You get this one, right? So you substitute in all the thing, at the end, you reach this one. This is the second equation that will help you in your assessment. Okay, so A, T, bracket, UR. This one you need to memorize. R double dot means double differentiation of your R. Of course, you'll be given R equation equal to R dot square, R double dot plus 2R dot theta dot. Okay, so these two set is, we don't ask you the derivation, but you have to memorize the V equation and the A equation. So this one and another one, the V one. Okay. So every time when you see the question give you polar coordinate, pull out these four equations. You write these four equations on the solution, then you'll get 4 marks there. Okay. Plus the diagram lah. Diagram you didn't know how to draw the radius and theta already ma. Okay. Important is the application of the equation. Same, you're dealing with vector. Magnitude is square here plus square here, square root. Okay. Same, huh? So important is to memorize what is your R component and theta component. Because you square this one plus square this one. So you need to memorize what is R. Is this one. Okay? You square this one plus square this one. And square root. So normally you find the R. So the step will be, you're given R, you differentiate 1 time, 2 time. Normally the step is like this. When you solve polar, first you draw R and theta component. Coordinate system, always the first one. Second one, what you do, you dy dx or dr dt d theta dt. You do the differentiation one. Normal second step is like that. Then you do double differentiation, dy dx square or d r dt square or d theta square dt. Why square? Because you have double dot here. You have double dot here. Okay, so these are the second steps. You do differentiation, then you substitute inside the equation. The next step is substitution. After substitution, you find one equation, then you find magnitude and give direction. So nothing complex here. It's like you follow the SOP. You know the question, okay, SOP, I do what? Then you follow. Then the challenging part is your differentiation skill. If you're weak, then you need to polish up. Okay. Right. Now again, in polar coordinate, your A will not tangent to the path. Just the reminder. Your A will not tangent to. You have one direction. Only velocity is tangent. Remember that. Acceleration can be any direction. This one. Okay. Acceleration normally it will point inside. But it not necessarily. It will point inside, but towards the center. It can be slanted a little bit, but it's still inside the curve. It won't go outside, unless your curve is another way around. Understand? Okay, so it towards the center. Velocity, yes, tangent. Which one?
I mean the 90 degree with the for the velocity and 90 degree is with the curve or
Curve.
curve. Oh.
No, it's always what mean by tangent is on the curve, but and then to the center, then what is the tangent and normal direction? What is the relationship between normal tangent is 90 degree? Okay, the VT and N direction is 90 degree. Okay, so yeah, so that is important is you know the direction. Okay, and the relationship between normal and tangent. Same with R and theta. Same with polar coordinate. Same. Okay. So this is a three-dimensional cases. I won't ask you three-dimensional, but when you do in your degree or master later, in normal tangent cases, we add in one component, we call it B just now. For polar coordinate, we use Z. Use Z to represent the X direction. Okay, and just expose you the equation we use. We'll add in one more component, which is a Z. Just now we have R and theta, right? So when you deal with three-dimensional, you need to calculate one more component, which is Z. But for diploma, we won't go into three-dimensional. Okay, quite complex, but same differentiation procedure. Same. So as you can see, the first component, second component still same, but it gives you the third component. Okay. We go for example, right? Now, same setup of question like what we seen in example 12 just now. Example 12 just now, we see tangent normal. But now, same circuit setting, but now in a polar coordinate. So in the park, amusement park, you know that there's a machine that you can sit and turn. So this machine, you have this one seat and it rotates. It's rotating in a horizontal circular path, which is 2D question, two-dimensional question. Radius R. We at that arm OB have an angular velocity, so V dot theta dot and angular velocity double dot. Determine the radial and transverse component of velocity and acceleration of passengers. Ignore the size. Here it asks you to use what is your understanding, derive the equation. Same procedure. You still need to draw the coordinate system, do the differentiation, and then the third part you don't have because you don't have value here. Okay, how you do? So you turn horizontal at B. Okay. So again, what you do, drawing coordinate system r and theta. Okay. So you need to find the change of angle and acceleration angle. So coordinate system, how you know this one is polar question? You are given r and theta. Okay, r and theta. Okay, so you look at the chair first. So at the chair, you draw a chair, and then the circular path, and then put in the radial and theta direction. Why theta this direction, pointing down and not pointing up? Why? Why theta pointing here and not pointing up? Where is the direction of the chair? How the chair rotate? You look at the diagram. You are given this arrow. This red arrow is given. So when red arrow given, you know that this chair was rotating this way. So theta always follow the change of angle, like this one. Okay. Then you put in T and N also, because it's a curve question. Although this one is in polar coordinate, but still you can use T, normal and tangent to help you to solve. Okay, so we have the coordinate system set up already. Any question? No, huh? Okay, so start with velocity. So R is constant. The R is constant. Because it's fixed, you do not go outside. When you turn, you do not become bigger and bigger. Fixed. So your R is constant. What happens if you differentiate a constant? What value you get, Nico? 0. So no matter how you differentiate R dot, R double dot, you get 0. So this equation you can cancel first one, cancel first one. Cancel here. Okay. So R double dot, R dot all 0. Then you know that velocity turning this way in tangent direction because of the red arrow just now. Your V is pointing down. Acceleration also in this direction. Yeah. All right. Then I need to highlight this one. Your acceleration is pointing in because you have a curvature motion. Acceleration always pointing in. All right. So your AR is negative. Why negative? Because your coordinate system you set just now. Where is the positive direction? Going up. But your acceleration is going in because of a normal direction. Okay? So your acceleration is negative sign here. Yeah. So from here also, you can see that when you do tangent and normal question, and it involves polar coordinate, the mistake here always forget the negative sign. For tangent normal question, you don't no issue. Your AN always positive because pointing in. But when it comes to polar, your R is going out positive. So you have a negative AR there. Yeah. So recall the equation that we learned just now. Just need to memorize. So A dot 0, okay, is 4 lah, that I asked you to memorize. Okay. So you know that R dot 0 cancel here. This one cancel because 0. Then you only left out this one. Okay. We go to this one. Then go to the acceleration. Also cancel the double dot R. Cancel the double dot R. You arrive at AR equal to minus r theta dot. Okay. So you know that you have two component. Again, you have radial component and angle component. So your AR equal to this one, A theta equal to this one. Okay. Okay, this is just a derivation or strengthening your understanding or how you apply the things. So when it comes to assessment, normally numbers will be given, same procedure. What you do is just substitute the value inside. Okay, and then find the resultant, square plus square, square root, you find the things. Okay. Angle, or sorry, direction, you don't need to tell already once you have a correct free body diagram. Really show the axis where is positive, where is negative. So once you get positive value, it means you follow what you draw. You get a negative means you go opposite the direction. Okay. Okay. Example 14. Okay. Example 14 is application of what we learned. So rod OA rotates in the horizontal plane like this. So if you see the diagram, it rotates anti-clockwise. You look at the diagram, the angle give you the arrowhead here, anti-clockwise. So theta was given t cube. This one change with t cube. Same time, collar B is sliding. This one sliding out because it's because of the inertia. Along OA with r equal to 100 t square means this is the r, but it changed with time because of inertia. If in both cases is in second, determine velocity acceleration of the collar when at 1 second. You freeze the time at 1 second. So what do you do? Again, you are given the theta, you're given the r. Write these four equations on your answer sheet. Establish the radial and tangent axis. How do you draw? You focus on B. Then, where is your R? R is here. Where is theta? Up or down? Up, because of this. Okay. So coordinate system, you draw a rod, you draw a dead one. Although this one look like three-dimensional, but actually it's a two-dimensional question. So you draw the axis, R and theta. Maybe you cannot see there is a blue line there, right? But blue line actually is a square equation. It's a quadratic equation, and it's a positive. Positive is a smiling face. That's why you see this one. You see this one as the blue line, actually you're plotting on the XY graph with the quadratic curve. Right? So quadratic curve, your A is positive, so it's a smiling face. That's why you see the blue line smiling shape. Okay. Then you have your VR pointing out. We are focusing on B. B is moving along this direction. So VR. Then you have V theta, this direction. Okay. Now previously, like the four equations that I asked you to memorize, you have VR, V theta, and you using the differentiation, you're able to find what is your VR, what is your V theta. Because theta is given, R is given. Both are in equation. The only things is you need to recall your differentiation skill. Okay. Then you just update the vector diagram. VR, V theta, there's a resultant there. Okay, V. Can? Then you go to the theta, the change of theta, gamma, because this is the rod. Purple color theta, inside one is for the rod. The gamma is for the B object. Okay, the next is substitution. So you do derivation, you get one equation. R equal to so and so square. So at 1 second, the R position is 100 mm because you just substitute the T is 1. You know that not starting, at 1 second R is 100 mm. What happens if you have, you differentiate R dot? Why you need to find R dot? Because the 4 equation you need to solve is, there's a R dot here. So you solve for differentiate this one, you differentiate this one, you get 200 T. So you substitute lah. In 1 second, you become 200 mm per second. Unit change a little bit. So this one is original. R dot means change of time. The unit must have overtime. Be careful on the unit. Okay, then you do double differentiation. You get change of acceleration. You get the acceleration R double dot. R double dot, you continue to do this one. 200 T, you differentiate, you get 200. Substitute, there's no T to substitute, but the answer is 200. Unit is second squared. Acceleration. Position, velocity, acceleration. Okay. Again, there's no complex here, only the differentiation scheme. Then after you find R, you find theta. Repeat the same process. This one, this T original angle at when it comes to 1 second is 1 radian. 1 radian. So okay, Nico, when you differentiate one time, this one become what? Differentiate. Theta dot. What do you get? Huh?
At 1 second.
Yes, at 1 second. What is the general equation first? Theta dot. What do you get? Don't tell me the general one. I want to see the theta equal to T cube. What is theta dot? Yeah, you can play the general equation in your mind, but
The answer is somehow 2 T square.
how come 2?
This was 3 T square.
Okay, so this is the first one. Then you differentiate one more time, Nico. What is the answer? Differentiate this one. Now you can do. Good. Okay, then you substitute time there. Okay, so time again, radian. Here is radian. You know how to do conversion to degree, right? 1 full cycle, you have 2 radian. 2 pi radian equal 360. So 1 radian, you do calculation, 360 divided by 2 pi. Okay, times the numbers you want. Okay, that's why you can get this one. So same, you substitute, you get all these numbers. Important is the unit. Again, position, velocity, acceleration. Same. Okay. So then you recall the equation. You just substitute only. Velocity, substitute. You get this one. V equal to R component plus theta component. Substitute only. Then you put in unit lah. This is the complete presentation. Acceleration also magnitude you know lah. Square root is V equal to 300 something for this case. You can find the angle by using trigonometry. All right. You have this component, you find this angle is a right angle, triangular, tangent equal to opposite and side. Flip the equation, you can find angle. Okay. So the total angle, you don't stop there. Why? This is the angle here, but the question asks you referring to origin here. Initial is what? What is the initial angle? Before it start, it already reached 57.3 degree. This is starting point degree, 0. Before it start already, like it reached at 57.3. Then 1 second, it will have in the 56.3. So this one plus this one, you get this one. A bit tricky, but you have to be aware. Huh? Which one, 300? Previously, okay. How you get 300? You find already what? This one? Just substitute. Okay. Your question next time should be not asking about 300. You should ask how this 300 come from. How you get, right, this one, right? Okay. Then the rest, you just find just now you find velocity, now you find acceleration. Same procedure. Complete the vector diagram, find the angle. Okay? So recall the equation. This one you need to memorize, no choice. But recall the answer you get from previously. Substitute, substitute, substitute. Okay, remember, don't confuse with this UR and U theta. You have two components, R component and theta component. Then you are fine. Just substitute and then you get one vector answer. You know that this vector, we want to find the magnitude and direction. So magnitude, square this one, plus square this one, square root. And then go inside here. Why this one negative? Because it's go inside. Then you have a triangular here. You have an angle. So again, tangent, this one and this one. Don't confuse with the negative. We only interest in the magnitude when you find the angle. Okay, so I'll show you the steps. Again here, don't forget the initial angle. This question is a bit complex. But this one, don't forget the earlier starting stage. Because the angle gamma here is 68.7, but before it start, it already locked at one position, which is theta. The 7.3 plus 68.7, you get 169. Okay. You see, okay. Next will be next lecture, right? We'll be looking at absolute dependent motion analysis, which is also popular in your test and final exam question. Right. So next lecture, we already done the linear, collinear motion already. Next one is that we're looking at pulley system. We pull something, something change. It's more on dynamic question. Okay, we'll look at this next lecture. Okay, we stop here.